Hello, today we are going to talk about tangents. Now you should recall that a tangent intersects the circle at exactly one point called the point of tangency. The other fun fact about a tangent line is that a line is tangent to a circle if and only if it is perpendicular. Now remember, perpendicular means that it forms a 90-degree angle to a radius drawn at the point of tangency. So if I draw my tangent line here, AB, and I call A my point of tangency, then I can draw a radius from the center P to A, and the tangent line is perpendicular to that radius PA. So I could erase this and I can say PA is perpendicular to AB. I can call PA a segment because it's a radius. Okay, so how are we going to determine if AB is a tangent to circle P? Well, if AB is a tangent, then this is a right angle, and that makes my triangle ABP a right triangle, in theory. So in order to check that, we are going to use the Pythagorean theorem. So, Pythagorean theorem. And so 17 would be our C, there's our A and our B. So we get 8 squared plus 15 squared. And we want to know if that's equal to 17 squared. So you get 64 plus 225, and over here we have 289. And that is 289, and this is 289. So yes, it is in fact a tangent. Then over here on number 2, we're going to have 5 squared because we're looking to see if that's a right angle. So 5 squared plus 11 squared equals 14 squared. And 25 plus 121. Over here we get 169. And remember, we're not sure if those are equal. So 146 and 169 are not equal, so that is not a tangent line. Okay, next it's asking us if JK's tangent, then find X. And guess what, guys? This is all Pythagorean theorem. That is all we're doing. So we're just going to keep on trucking here. So we have 10 squared. Oops, looks like I'm looking at the wrong one here. We have 7 squared plus 19 squared. And that's going to give me 410 equals X squared. And we take the square root. And we get that X is approximately 20.2 when we put that in the calculator. So if I go over here to Desmos and I do the square root of 410, I get 20.2-ish. Then we're going to have 11 squared plus, 11 squared plus, this is X, equals, now look at this. This is 7, but remember that 11 is our radius, and this is a radius. So our whole hypotenuse here is 18. So we've got to remember to do that in due course. So 121 plus X squared equals 324. And then we subtract 121 from both sides. We get X squared is 203. And we're going to take the square root of 203 to get 14.2 approximately. All right, now for question number 5, they only want this part, and we know that this part is 10. So I'm just going to call this whole thing right here, my hypotenuse, C for now. So I'm going to get 10 squared plus 24 squared equals C squared. We get 676 equals C squared. And then if we do the square root of 676, we get 26. So C is 26. But remember, we need X. So X is 26 minus 10, or 16. All right, here we have our point of tangency again. And if this is 11, then this is also 11, which makes this leg 22. So we get 22 squared plus x squared equals 25 squared. 484 plus x squared equals 625. And x squared is going to be 141 because we subtract 484 from both sides. So now we're going to take the square root of 141. We get 11.9 approximately. Number 7 now. We've got 3.5 here and 3.5 here, which makes this whole thing 7. This is our right angle, so x is our hypotenuse. So we're going to have 7 squared plus 6.4 squared equals x squared. I'm going to do this in my calculator. So 7 squared plus 6.4 squared gives me 89.96. X squared, and then to get x, we're going to take the square root of 89.96. We get approximately 9.5. Approximately 9.5. All right, so last one for this page. We've got our right angle here. This is x and this is x, which means that this leg is 2x. So we have 2x and we have to square the whole quantity. Plus 7 squared equals 25 squared. So 4x squared plus 49 equals 625. Subtract 49. And we get that 4x squared equals 576. And we'd have to divide by 4. And we get, I'm running out of room here, we get that x squared is, again, I'm going to go back into my calculator here. 576 divided by 4 is 144. So x is 12 after we take the square root. Then finally 9, I'm not sure if this is in your notes or not, but we're going to keep going. So we have this is an easy one, 20 squared plus x squared equals, and then we have this, but we know that that's x. So we're going to have x plus 10 squared. And actually, we're not going to do that. That's a quadratic, and you guys have not gotten there yet. So now let's talk about some more tangent line properties. So this one is that if two segments from the same external point are tangent to a circle, then they are congruent. So we've got this point out here, which is B. If we draw from B to A, and A is a point of tangency, and C is also a point of tangency, then this piece is congruent to that piece. And then a polygon that is circumscribed. Circumscribed means that it only touches one point at a time. So there are all these points of tangency right here. So like this circle just touches here, and that means that all of these little pieces are all congruent. okay? So now, if we look at number 10 over here, we should know that assume that the segments that appear to be tangent are tangent. So that's our first little thing. So if we are tangent at A and we're tangent at C, then this is going to equal this. So 5x plus 23 equals 8x minus 19. And we solve by doing our order of operations here. So x is, I think this is 14 there. And then the same thing here. This is going to be the same as this. So we subtract 8x from both sides, 6x. We add 13. And so x is going to be 3. Now, this one is asking us to find the length of SV. So in order to do this, we have to remember a whole lot of things here. Firstly, that those are right angles there, and also that this side is congruent to this side. So first we have to find x. So we're going to have 10x minus 41 equals 4x plus 7. Subtract 4x. And we're going to add 41 to both sides. So we get 6x equals 48. So x is 8. Now, if x is 8, then this side is 32 plus 7, or 39. So that means that one of our legs is 39 and the other is 17, because now we're just going to look at our triangle here. And it's a right triangle with a leg that's 39 and a leg that's 17. So we're going to have 39 squared plus 17 squared equals, I'm going to call this c squared right here. That's our c. And to do that, we're going to have 1810 equals c squared. And then we're going to take the square root, and we get that it's approximately 42.5. Okay, so our next question asks us to find the perimeter of DEFG. This is not as hard as it looks, guys. If this is 16, then this is 16. If this is 9.5, then this is 9.5. And finally, if this is 11, then this is 11. And so then we're going to add all of our sides together. So this side here is 16 plus 9.5, which is 25.5. And then 11 plus 9.5 is 20.5. And then this side is 27. And then we're going to add all of our rainbow colors together here. So 27 plus 25.5 plus 20.5 is 73. So our perimeter is 73. And then the same thing is happening here, only we're given different parts. So if this is 27.1, then this is 27.1. And if this is 27.1, then this has to be 52.5 minus 27.1. And I'm going to do that over here because ain't nobody got time for that. 52.5 minus 27.1 gives us 25.4. So that makes this 25.4, and that's 25.4. And then that's 23. This piece right here is 23, so this is 23. And that makes this corner here 37.5 minus 23, which is 14.5. And this is 14.5. So then we add all of our pieces together. So we've got 14.5 times 2, because that's those. Then we have 27.1 times 2, and that's those pieces. And 25.4 times 2, and 23 times 2. We're going to add all that together. So this is 29, 54.2, 50.8, and 46. And when you add all of those together, you're going to get 180 as our final answer. So I hope that all makes sense, and we're going to get plenty of time to practice.